warm welcome to you all at my channel. So, in the previous video, I had explained the use of recurrence equation and how the solution of a recurrence equation is derived. And now I'm going to illustrate how we implement the recurrence equation or the solution of a recurrence equation in order to obtain the time complexity of the Fibonacci series. So if in case you have not watched my previous video, I would highly recommend you go and watch the previous video. I will be posting the link of the video in the description below. So now, whenever the word Fibonacci strikes in your mind, the only function that you always have to remember is f of n is nothing but f of n minus 1 plus f of n minus 2. This is the equation that you should never forget while you're implementing Fibonacci series. That is always going to be the constant. And then, now I'm going to try to implement a particular value of, let's try putting the value of x raised to n in this equation. What will that give us? It will give us x raised to n minus 1 plus x raised to n minus 2. So, after getting this is the equation that we have got after implementing x raised to n in this equation. So now we'll call this equation 1. Then we are going to divide this equation by x raised to n minus 2, the complete equation. So what will we get? We'll get x raised to n divided by x raised to n minus 2, that is equal to x raised to n minus 1 divided by x raised to n minus 2 plus x raised to n minus 2 divided by x raised to n minus 2. What will that give us? It will give us x squared equals x plus 1. That is the characteristic equation that we have got. Let's not call it 2 right here. We'll just take it on the left hand side, making it a quadratic function, that is x squared minus x minus 1 equals 0. So now we are going to solve this quadratic equation, that is x squared minus x minus 1 equals 0, which we call it the second equation. So we are going to use the formula that is used for solving a quadratic equation, since we cannot split this term in the requisite term. So we'll have minus b plus minus root of b squared minus 4ac minus upon 2a. So we have a equals 1, which is the term here, and then we have b equals minus 1, and we have c, which is a term here that is also equal to minus 1. And so substituting in the equation, we get minus and minus will become plus, and so we have 1 plus minus root of 1 minus of 4 times 1 times minus 1, complete under root, and I will divide it by 2 times of a, which is, that is 2. 2 times of 1 is 2. So that will give us 1 plus root of 1 plus 4 plus minus, divided by 2. So which gives us the root as 1 plus minus root of 5 divided by 2. So if you have seen my previous video, you can recognize these two terms as Sn and Tn. We have S of n equals x raised to n in this case, that is equal to 1 plus root 5 the whole raised to 2 raised to n, as we had discussed in the previous video. And we also have t of n equals x of n, that is, putting the root in that equation, we have 1 minus root 5 divided by 2 the whole raised to n. let's recollect the formula that I had explained to you. What was the formula? Xn equals, we had Xn equals Cn, C1, where C1 is a constant, which we need to find. And then we had Sn plus C2 of Tn. This was the equation. So hence, the function here, that is Xn, is equal to C1. I'm putting the roots that we have got, that is 1 plus root 5 divided by 2, the whole raised to n, since Sn is nothing but the root of those roots raised to the power of n, plus C2 times 1 minus root 5 divided by 2 times n. So now clearly from this equation it's evident or current that it is dependent on these two set of values, and out of these two set of values this value is greater, which is 1 plus root 5 divided by 2 is going to go faster as in comparison to 1 minus root 5 divided by 2. So according to the time complexity rule, this function is going to dominate, and that is going to determine what will be a time complexity, which is for f of n we have, that is for n as a sufficiently large input. We'll ignore this constant as well, which is not gonna matter, which is nothing but O of 1 plus root 5 divided by 2 the whole raised to n. And when we calculate this value, we get it as something around about 1.61, which is what we call it as the golden ratio. So the time complexity of recursive Fibonacci series is O of 1.61 the whole raised to n, where 1.61 is what we call it as the golden ratio. Golden ratio signifies of how a Fibonacci series is intimately connected. So that's it from this video. Thank you for watching. So please like, share and subscribe for more interesting content. Thank you and have a nice day.